In this video, we're going to take a tour of the NetKernel nCoDE composite development environment. This is just a basic install of NetKernel with all the latest updates and the nCoDE environment installed. I'm going to use a new capability of the new module wizard and create a module. Let's just call it Demo. I'm going to attach it to the front-end fulcrum so I can make HTTP requests to this address space, and when it offers to me to create a script, I'm going to allow it to set up an nCoDE environment for me, and I'm going to leave the dynamic palettes option selected, which I'll talk about a little bit more later. So I've created that module now, and I can issue a first request to that, and I get hello world when I issue a request to that service. I'm now going to go to the Space Explorer, and I'm going to look for my new instance of nCoDE. All instances of nCoDE can be discovered from this new tool in the Space Explorer. And we see my demo space here contains an example nCoDE endpoint. I've got some other ones in the system as well, but let's have a look at the example one I just created. The Space Explorer is a tool that allows us to look at all of the address spaces inside NetKernel and look at the endpoints inside them. Here we see we're looking at the example nCoDE endpoint, and we see that the visual and development environment for nCoDE is actually exposed as a plugin into the Space Explorer architecture. So here we see I can start to edit and play with the nCoDE environment inside the Space Explorer. By clicking this icon here, I can expand the system up to full screen. So I'm going to leave that page and expand it to full screen. And here we can start to work on the tools and this development system. So first off, we need to understand that the nCoDE runtime is a physical service that can supply and provide any number of logical endpoints that can have their own grammars and their own interfaces. Here, for example, I've just got the Hello World tab, and we see that the name of this service is Hello World. It's got an ID that's generated for us of nCoDE test Hello World, and we see it's got an interface. Its resource-oriented grammar is res demo service. So we can change this if we wish and call it res demo hello. And now I need to change my request in the web interface to call demo hello, and I did something there that you should need to know about, which is until I actually click save, that change isn't committed to the address space. So now I've saved it, I can make a request for demo hello and I get hello world. That leads me to the next point, which is that the cog icon here allows us to configure the settings for the system. This out of the box is set up with the very basic defaults, so there's really little we can do here. So let's click that tool. We see here there's an autosave feature which I'm going to enable, which means I don't have to remember to click save each time I make a change. And we discover that nCoDE has looked through the set of address spaces in my system and has discovered that there are a bunch of libraries that are exposing palettes to the address space, and we can see that nCoDE has looked through the public address spaces that are known to the system and has discovered that many of them are publishing a palette description. And a palette description is a way for the nCoDE environment to find a set of endpoints that can be exposed and used in a system. And we see there's quite a comprehensive set here. So I'm just going to basically enable everything for the time being, and this just will show us what's available. It's going to take me a moment to select all these. You would normally not select the entire lot, you just use the ones that you want to have. The system's now going to reconfigure itself because nCoDE is now saying I'm going to dynamically import all of those spaces that are exposing palettes, and we see that it picked up that change and my palette tools just dynamically changed there. So you see now that I have, for example, in my accesses tab quite a rich variety of tools available: JavaScript, Groovy Runtime, Wiki Parser. Let's use the Wiki Parser for example. So let's drop that onto the page. Let's get rid of that link, and instead of Hello World, let's have Hello Wiki. Save that and send that to the Wiki Parser and re-request that page. And what I now get back is a div block containing the parsed wiki text. And obviously I could pass that into a templating environment, or I could just mark it up as HTML with HTML MOIM type if I wanted to, so the browser would respond and treat it that way. I've got search index tools available here. I've got various languages and programming environments here. I also have available some low-level tools coming out of the Layer 1 library. So I've got things like golden threads. I've got tools to work with the HDS format, which is one of NetKernel's native internal resource models. I can make execute native processes on the operating system. I've got a set of XML tools, universal validator, Saxon and XQuery libraries, XSLTs and compiled XSLTs, a comprehensive range of HTTP client tools, as well as server-side front-end tools for interacting with HTTP requests coming in from outside. I've got a wide range of tools in the RDF processing palettes coming from the various RDF libraries I've currently got installed in my system. Here's a bunch of tools for interacting and processing with SOAP messages. So for example, let's create a new SOAP 1.1 message and send that to the response. So it'll just be a really basic SOAP message. Let's have a look at that. Envelope, body, empty. So it's not a very interesting thing. A set of image processing tools, a set of SQL transform tools, SQL query tools, so I can make a SQL query against a database. There would be the query I wanted to use. That would be the connection pool configuration that this query would require. So all of these tools are available now for me to build a system out of. And obviously these are the basic tools that come in various libraries. The interesting thing is that we can add our own capabilities, and we can either do it by adding systems built in nCoDE, or we can write low-level Java tools and expose them as palette items into nCoDE, or just for general use by arbitrary NetKernel systems and tools. So for example, let's add Groovy, and let's write a little simple Groovy hello world. So this is my Groovy script, and inside any script in NetKernel I have a context object. So I'm going to use the NKF API to write some Groovy code and issue that to the response, and rather than take the SOAP message, I'm going to connect the Groovy as my response. These palette components here don't affect the application. They're just there in the meta model of the system. It's only the process that is consistent with the connected components that actually gets executed. So let's now run hello from Groovy, and I get a missing method exception because I've mistyped something. Pretty sure context.create response from. Okay, I reload that to get hello world Groovy. When I look at any one of these components, so say for example I look at an accessor like Groovy, if I double click it in the palette, the system goes away and discovers its documentation from its library, and we can then inspect it and see how it works. So I could have, for example, cut and pasted that piece of code from the documentation into my tool. It would have set the MIME type for me correctly, and then I could have run that piece of code, which might have been convenient. I wouldn't have got so many typos. Every tool in the system can access its documentation that way, And obviously, if I'm interested in the context from which this documentation comes, I want to learn about the guide to the system, then I can usually always click to the book and see it in situ with the rest of its documentation. This just gives me the quick reference to understand what the arguments are for and what the types are and so on and so on. Obviously, in normal use, we don't work in just one space like this. We want to be able to add and compose together tools to create composite assemblies, and so we can add any number of palettes, any number of tabs to our system. Each one of these is its own endpoint. So if you're familiar with tools like NetKernel's mapper, the mapper is a single physical endpoint that exposes many logical endpoints, the mappings inside it. nCoDE is very similar. nCoDE is a single physical runtime, but each one of these tabs on the bottom is actually a logical runtime, logical endpoint in the address space. So let's just prove that by creating a new one. Let's call it video example. Let's just give it a name, videg, and we'll just give it a basic grammar videg. So if I now close that, I'm just going to pop down the full view and look at the runtime. So if I go back to the development space over here, and I see where that nCoDE runtime is implemented, we see that I've got my physical endpoint nCoDE runtime here, and it's exposing 3 logical resources. The first one is that hello world resource, which you saw. The second one is the video example I just created. So that tab is now appearing as a logical endpoint in the address space. And also it's exposing an endpoint called dynamic import config. And this is the little bit of magic that's going on inside the RSC world. It's a very simple RSC pattern. What the nCoDE endpoint is doing is, in the mode I had it set up, when I set up the new module wizard, I asked it to enable dynamic imports. And what that does is the nCoDE endpoint goes and looks at all public address spaces in NetKernel and looks for a palette entry called res etc system cd palette. And each time it finds one of those, it exposes it in that list of clickable imports that are available. The ones that I've highlighted then get exposed as the resource called dynamic import config under this endpoint. And then we see down here we have in the address space that the new module wizard set up for us a dynamic import endpoint. And this dynamic import endpoint is just receiving and using a resource which is a list of the spaces it's being told to import. So this import is using this set of spaces that the endpoint is saying that I want to use. So this import is dynamically pulling those spaces into the system for me. And if I change the import by clicking different selections, then this dynamic import will dynamically adapt and import those different spaces for me. So I've got a zero configuration environment. I don't have to make any import decisions. It's all just directly under my control.